Hello, everybody. In this short video, I'm going to talk about how to do terminal input-output in C using fgets and scanf, and I'll compare that to using scanf and show you why using scanf is really not a good idea. In fact, it's particularly not a good idea because if you use scanf, I'll take credit off. It's not a good solution. Okay, so I've created a couple of demo programs. Here's the first demo program, which is using fgets and scanf. So let me explain a little bit how this works. Okay, actually, let me run it first so you can see what it's supposed to do. Okay, so it asks you the day and the month of your birthday. So for example, 31/1. And then it asks you your first name and your last name. And then it figures out whether your birthday has already happened this year or not. Okay, so in my case, my birthday is the 31st of January. My next birthday will be in 2021. On the other hand, if I were to enter, let's say, 12/10, in other words, the 12th of October, then as you see, it will tell me that my next birthday is the 12th of October, 2020. Okay, so that's what this program is supposed to do. And here is the code. Okay, so in terms of terminal input-output, this is scanf. I'm sorry, right, this is the wrong one. There we go, okay. So in terms of terminal input-output, you already know that for fgets, you need an array of characters. So here I've decided that I will make it be 32 characters long. And I'm going to use this every time I ask the user to input some information, both for the numbers and also for the names. And then I have a couple of integer variables for my birthday and birth month. And I also have variables for getting the day of the month, day, the month, and the year today. Okay, you don't have to really worry about how that works. This code will do that for you. Okay, but you don't really have to understand how this works. You just have to know that at the end of this code, if I run this today, today day will be 5, today month will be 9, and today year will be 2020. Okay, so here's where we start doing the input. So I print several lines of instructions to the user, and then we call fgets. Now, what is fgets doing? Well, what are the arguments? Fgets has 3 arguments. The first argument is the character array that we created before, and that's where the information that is being read from the terminal is going to be stored. Okay, the third argument is stdin. Now, as I've explained several times in class and in the lab sessions, stdin is a special word that means read character data from the terminal. Okay, so when you are typing, that means that it's coming from stdin. Okay, the middle argument tells me the maximum number of characters that I should read. And fgets will stop actually when it's read 1 less than that maximum because it wants to be able to put a 0 at the end so that C will know where the string ends. But the important part about fgets, and this is what makes fgets scanf better than using scanf, is the fact that you can limit the number of characters. Okay, well, that's one of the important things. Okay, so after I call fgets, anything that I typed on the keyboard, up until either I hit return or until I have input, in this case it would be 31 characters, is getting stored in this character array. So the first character that I type gets put in the first location in the character array, the second character I type gets put in the second location, and so on. So the next step is to use scanf. Scanf goes through the data in a character array and tries to convert it according to the instructions we give it in the second argument. Okay, so this is where it's reading the data. It's not reading it from the terminal. It's reading it from memory where we stored it using fgets. Okay, this, which is called the format statement, tells me that what I'm looking for is two integers, %d. And then these two arguments tell me when I find those integers and convert the characters to integers, where should I store the results? Okay, so the way that scanf works, if I type, let's say, 31 space 1, as I did the first time I ran this program, it will start looking through the character array. The first thing it will find is a 3. Okay, that's possibly part of an integer. The second thing it'll find is a 1. That's still a digit, so it will continue. Then it will hit the space. It'll say, okay, that's not part of an integer, so I've got the digits 3 and 1. I will convert that to be 31. And then it will continue, in this case, trying to get another digit. Okay, so that's how fgets and scanf work. And in this case, we're getting, as I said, numbers or integers. We do the same thing to get the names, the first name and the last name. Okay, so fgets works exactly the same way. It's storing the characters as I type them. Well, actually, it doesn't see them until after you hit the return. But will only store up to the limit of what will fit in input. So 31 characters plus the 0. If I type fewer than 31 characters, actually it'll include those characters, and it will also include the new line character, which ends the line. Okay, but we won't really worry about that right now. Okay, and then the scanf, in this case, we're looking for a string, not an integer. So what this does is it starts at the beginning, first character in input, and it simply takes each one until it gets to white space. White space either being a blank or a new line. And then it stops. And it puts the results in the third argument. So you notice that in the case of looking for the digits, I have two format statements. I have two arguments. When I'm looking for the first name, I have one format statement and one argument. Now you may ask, why don't I have to put this ampersand in front of first name? We'll learn about that in a few weeks. Okay, just for now, if you're looking for numbers, you do need it. And if you're looking for a string, you do not need it. Okay, so that's the way that the terminal I/O works when we're using fgets and scanf. Okay, and then down here is the logic where I simply compare the month to today's month and the day to today's day if they're the same, and that tells me whether my birthday is this year or next year. And notice if it's next year, all I have to do is just add 1 to the year when I print it. So you already know, I think, how to use printf this way. So you've seen how this program works if the user types what you expect. What happens if the user types something you don't expect? Well, the first question is, what if the user doesn't put in both the day and the month? Okay, so what if I just put in 12? Okay, well, it doesn't give me any error message. I don't have any code in there to check. Okay, so then I'll put in William, James. Okay, and you see what happens. It's not exactly correct because since there was no second string of digits, it never changed the value of the month. As you see, I started out the birth month and the birthday to be 0, so it just stays at 0. So it's not great, but at least the program behaves more or less the way I expect. Another kind of problem is, what if I put in a really long name? Okay, I have room for 31 characters plus the 0 that terminates the string. What if I put in more than that? So let's put in 1210, a very long name, and this must be longer than 32. Okay, so this is a little bit strange. Okay, notice what happened. Okay, it took up to here. Okay, and if you counted, so in other words, it took the first name up to here. And if you counted that, you would find that's 31 characters. And it used that as the first name. And then it stopped. Okay, it didn't do anything. And then it asked, what is your last name? But it didn't wait for me to type anything. The reason it didn't wait is because the user has already typed these characters. Okay, so it reads those characters and uses those for the last name. So as you see, it treats the first 31 characters we typed as the first name, and the remainder is the last name, which isn't right, but it also isn't fatal. Okay, it doesn't cause the program to crash. It doesn't really cause any terrible effects. Okay, but I think you can see that it's important to have that limit, because otherwise, well, we wouldn't have room for any more than the 31 plus the terminating. Okay, notice input is just only 32. Okay, so that's the fgets version. Let's look at the scanf version. Okay, the only difference is I took out fgets and scanf and I replaced it with scanf. Okay, for the three things that we asked for. Everything else is the same. Okay, it's still, I don't have input anymore because I'm not using it, but I still have 32 characters for the first name and the last name. Okay, and you'll notice I get that directly. And you may think, oh, this is really good because it saves me one command each time I want to get something. But as we'll see, there are problems. So let me run this, show you. So if everything is fine, if the user enters the data that is expected by the program, this program works lovely. It works perfectly. There's no problem. Okay. The real issue with scanf, as opposed to using fgets and scanf, is what happens when the user does not do what you expect. Okay, so first of all, let's look what happens if the user doesn't realize that she's supposed to type two numbers on the command line. Okay, the program is expecting two numbers, the day and the month, but what if I didn't read very carefully and I just put in the month? Okay, and the program is just sitting there. It doesn't continue, it doesn't do anything. This is not good. Okay, this is confusing, and it really is not the way the program should behave. Now, maybe I'm smart and I think, oh, wait a minute, maybe I need to type the month. Okay, and then because it was expecting two numbers, now that I've given it two numbers, it will continue. But the fact that if I don't give it the two numbers, it just sits there, it hangs, it's not good behavior. It's worse behavior than what happens with the fgets. If you skip it in fgets, well, you get a 0 value. And then if you look at the results, you'll see that there's something wrong. Okay, so okay, so it's okay, but only if I figure out that, oh, I guess I need to type the other number. An even worse problem, though, happens if we type too many characters. Okay, so let me put in the 20th of August. Okay, and I'll put in a very long first name and a long last name. Okay, and look what happens. We get total garbage. We get total garbage. Why? Because what's happening is there's no way that scanf knows to stop. So this is probably about 40 characters, maybe more like 50 characters. And scanf reads them all. Okay, so it starts out putting them in first name, But once first name is full, it continues to write that data into memory. And what it's actually doing is it's actually overwriting the variables that are declared before it. So that's why we have garbage, because we store characters in memory that was not part of first name. And the same is true of last name. Okay, if you look here, you'll notice that when I print first name and last name, in fact, it's all part of what was last name, because it's overwritten the data that I wrote in first name. Okay, so this is very bad. And you may say, well, it's stupid of the user to type too many characters, but the user doesn't know. The user doesn't know how many characters you expect. You could tell him or her. But again, do you expect the user to sit there and count the number of characters in his or her name? That's not really reasonable. And as we'll see, if you put really a lot of characters, let me do something else here. Your program will crash. Okay, segmentation fault core dump in Linux means that your program has crashed. What does that mean? It means that you wrote into memory not only memory that belonged to these other variables, but memory that doesn't even belong to your program. Okay, so you've tried to write into illegal memory, and so your program crashes. Okay, so this is why SOBA never uses scanf, because it's dangerous. Okay, SOBA is a very smart cat, and when he programs, he always uses fgets and scanf, even though it's a little bit longer. Okay, he knows that he wants his programs not to crash. There's one more program I want to quickly show you. Somebody asked a question last week, and I didn't answer, about why do I always use so much larger buffers, even when I know that I only want a very few characters. So I have this program here, okay? Very simple program. I ask the user to input a number between 1 and 20, and then based on, I use fgets and scanf, okay? So this is not related to the question of using scanf. And I test the value and tell the user whether they entered the correct value or not. Okay, so if I run this, if I give it something reasonable, okay, it'll tell me it's okay. If I give it something larger, okay, it's working correctly. Okay, because I have here 16 characters worth of input. But you may say to me, well, wait a minute. You said that you only wanted a number that was up to 20. So why don't I change it? I mean, why should I waste memory, right? Ha ha. It's not really wasting very much memory. But I know that if the user is following instructions, I should never enter more than 3. Okay, so let's say I make it be 3. I have to recompile. Oh, I forgot the semicolon. Okay. Okay, so let's run it again. Okay, if I type 1, it's okay. If I type -2, it's okay. But if I type 2099, look what happens. Okay, because I'm using fgets, okay, it's only going to get 2 characters. So it mistakenly thinks that I entered a good value. So the lesson here is make your buffers these are sometimes called buffers. Make your character arrays that you're using with fgets long enough that it's very unlikely the user will type something longer, okay? Much longer than the minimum or the maximum number of characters that you think is very likely. Now, you may say, oh, why do I always use like 16 or 32? You can put any number in there. As you see, I just put 3 in there. I tend to use multiples of 2, powers of 2, because very often compilers prefer to have your data items be multiples of 2. And if they're not, they sometimes put extra memory in there to make it be a multiple of 2, just because that makes the access to memory more efficient. Okay, so that's all I want to tell you today. If you have any questions about this, you should maybe ask a question in the list for lab next week. And I'm going to put these programs up on Windows so you can try them yourselves. So thank you very much for listening.